going to present tonight, so bear with me. So yeah, the title of this is Teleporters and Holodecks and Replicators, oh my. So for those that are familiar with Wizard of Oz, we're in the Emerald City, and I thought I'd pay homage. So a little bit on my background and my co-founder's background. So I got started during an AI winter. You couldn't get hired in AI. You could either work in games, research, or military, and the first two didn't really pay all that well. I remember my starting salary as a game developer shipping AI for Activision was around that of a teacher. And I found myself at Apple. They needed C++ developers, and I just got off of 4 years of making video games for PlayStation, GameCube, and Xbox. And I failed my first interview and ended up on failing upwards because the first interview was for games on the iPod. So you know how that took off, right? Who plays games on an iPod? Who has owned an iPod?
Oh, I do.
Okay, cool. Not that old. So I actually ended up failing. The question was I misremembered the question on the equation of distance, which was like the easiest thing to remember. So I failed upwards, and I found myself on the Mac OS team. So we only had 22 million users back then. So today, Apple has roughly about 2 billion users off of phones and devices. And so I was there when Steve Jobs was there, so we got to meet as my first internship there. Steve Jobs and Johnny Ives and Ron Johnson, who ran the Apple stores. And then after that, I knew that Apple would never care about games. So I ended up creating the iMovie of games, and the idea was sort of based on the idea of a holodeck, where how do you interface with a holodeck, right? You say, hey, holodeck, I want a red chair, and a red chair appears. So we utilized research from Carnegie Mellon's natural programming group to turn natural language into code, and that company was founded in 2007. So this is like 10 years before OpenAI and language models became popular. My second company focused on natural language to images in 2013. So roughly 10-ish years before Midjourney. And now we deal with digital twins. And so around that time that I was working in AI and in video games, I met my co-founder who was also shipping games for Activision. And he found his way onto the Extreme Blue team at IBM, and then just got hired by Google. Spent 15 years there. He worked on Google Brain, Google X. He did the first 3D reconstruction project for Google Shopping. And he worked on a project called TensorFlow, which is like, 40% of the industry. And there's a guy named Ilya Sutskever. I don't know. You guys know who he is. Who knows who Ilya Sutskever is? Okay, so without his other co-founder, he's worth $32 billion, so twice the price of Perplexity. And Ilya was the former CTO of OpenAI. So my company Curie works on digital twins, but when we got started, the idea was based on first principles, that in video games, we have this thing called a scene graph. And it's basically tracking where everything is at any given time. And you have 100% knowledge of anything, right? Because you are the creator of the game, you know where anything is. And so in a game, you know what's in what. So we are in a building, right? This building is in Bellevue. This Bellevue is in Washington, and so on and so on. So that's the graph. But we don't have that for the physical world. And so we ended up building a demo for Apple. I didn't know that they cared about Apple Intelligence at the time. It wasn't even called that. But the idea was, what if you could have like a Siri for your camera? And we created this demo for the Apple Store. And the idea was, what if you could Face ID things? Right, so who uses Face ID? All right, how many times have you used it? Would you say like a dozen times? Like 100 times a day? Yeah, so some people say 100 times a day. So you find it pretty reliable, right? So the idea was to have a bottom-up approach to reconstruct that scene graph of reality using a human version of street map cars, right? Which is our cameras. So, eventually this was predicting the idea that eventually the phone would get replaced by glasses. Who here wears glasses? All right, so we have a form of augmented reality that requires, I guess it's powered by the sun, but it requires no batteries, and 300 million people are required it. 2 billion people, wear it for shades. But we're already, the idea was that eventually this behavior of purchasing this type of product over and over again would start to rival that of phones, right? There are 6 billion phones. There are, 2 to 4 billion shades that people tend to buy on a regular basis. Some of them are almost the price of phones. And so then the pandemic hit, and everything shut down, right? So relying on a in-store behavior wasn't going to fly because people couldn't go into stores. And so had there been no vaccine, we would have had a monopoly on the replacement for stores, right? So we sought to create a replacement. At the time, in early 2000s, generative AI would just produce gray blobs. But it would produce something that resembled the shape of the object. So, and this is where we are today. So we were featured by Tim Cook for our work with StockX, which is the world's largest collectible site. We beat up Gucci, Decathlon, J.Crew, and mostly because they built products that didn't complete what Walmart calls the treasure hunt. The ability to come to a moment of truth by seeing multiple items at the same time to be able to make a decision. And most of these applications didn't learn from retail, didn't learn from merchandising, and they only showed one product at a time. And so that's how we beat them. So today we have the most accurate model on the planet. We tested this, and we're keeping it to ourselves, but we're not letting you know. And the reason for this is that they're pulling from video game data, right? So games are kind of like, who's here is familiar with Sears? Who knows that like Sears used to be the original Amazon, right? So they used to send these catalogs out to like cowboys and people in the Yukon and be like, hey, like you don't have a store like in New York, so we'll bring the store to you. So they hand created the illustrations of every product. So that had to be hand drawn. Eventually those jobs were replaced by automations called digital cameras, right? And so in video games, you have to hand make these things, right? That's why Marvel films are so expensive. They're bespoke. Video games are bespoke. They're handmade. And so by using artificial intelligence to create the content, you're 100,000 times more cost effective than doing it by hand. And because these were pulling from game data, they're trying to reconstruct from latent space, like basically a Frankenstein's monster of things that resembled Mario and stuff that was in fantasy. But we pull our data directly from photos, and we're able to get closer to photo realistic results. So that's what Curie does, is that we're a 3D reconstruction technology that has probably a 10-year head start since we were working on 3D reconstruction on Google Shopping back in 2016. Okay, so what does this have to do with Star Trek. So in Star Trek, nearly everything from Star Trek has made it to the physical world, right? We actually beat that prediction, right? Star Trek takes place in what, the 23rd century, 22nd century? So we beat it. We beat that prediction. But there are a few things in that show that became tropes to move the story along that we haven't built yet. A lot of it's because of physics. We don't have force fields. But in essence, what these tropes are doing is that they're distinguishing the relationship between matter, like things, this world, and data, right? How do you get these things to work? Well, you have to convert things to data, right? So teleporters. Who here would want to use a teleporter? Okay, you don't want to use a teleporter because, like in Tron or I don't know, Honey, I Shrunk the Kids, it has to basically destruct every atom in your body, rip it apart, and effectively kill you, and then reconstruct you from the matter that's already there. So if that matter is not already there, then it's going to be incomplete. So basically, it's 3D printing you, a copy of you on the planet, right? So, you know,
So Michael,
Okay.
I would offer to use a pre-porter if you can put me together before you destruct me.
Okay, there you go. Well, that's how you get William Riker too. So deep cuts. So yeah, like the essence is that you're converting people to data, sending the data over, and then using that data to reconstruct you. Holodecks, very similar idea, right? You have all this information, and you can now use that information for entertainment. Now you can be anywhere, anytime, right? Anyone. I always ask the question of where do the things in the holodeck come from? Are they made by sweatshop labor, by trillions of aliens? Or was it made by AI? So I think we've solved that problem. And then we have replicators, right? So basically 3D printing on an atomic level. And so, we solved this problem. We've effectively solved the abundance problems for food and a lot of other things, right? So you've almost eliminated poverty if, we all get access to it. But yeah, you're converting data to matter. And so in essence, right, we need AI to be able to serve the same functions of these. So what are all of these things doing? They're moving things from point A to point B, right? Like regardless of where you are, when you are, world models are a new type of AI that sort of gets you there. And the number one application of these world models is what Sen-Chin Huang calls to physical AI, right? The application of artificial intelligence to the physical world. And it's this world that feeds us. So how would this even work? Well, today we use language models, and language models are probabilistic, right? They are determining whether or not, what is the likelihood of B coming after A in the alphabet. But the problem is that language in general is lossy, is faulty, right? How do you know if something is true? If you could create an AI that could figure out if something is true, then it would kind of solve itself. So with these models, you're sort of limited, right? It's kind of like hearsay. In a court of law, hearsay is always going to be trumped by sensor data. by what is absolute truth, but what we can observe and record from other senses that we have to have a lived experience of those events, as opposed to what is said. And so ultimately, I feel that like language models are a really great interface for discussing knowledge, talking about information, but it becomes a very poor representation of reality itself, of the world. And so there's this new architecture called world models. And world models are trying to reconstruct what we understand about the world fundamentally from a deterministic way, right? It's using information and techniques built from simulation in order to be able to represent and understand this world, right? So if we're successful, a world model would be indistinguishable from this one. A world model would be able to represent every pathway we can think of. I don't know if you've seen like Westworld season 3, but they have the ability to do Doctor Strange, the multiverse, through simulation, and you should watch it because that's the closest thing representation we have in media of that. But there's practical elements to this. So, for example, we have these things called planograms. So, who's here been to a retail store? Do you know that like these retail stores are planned in Excel? Yeah, so we still have 2D representations of these 3D environments that have persisted to this day, right? Excel are basically tables that have been used by the Medici, right? Like this is hundreds of years old to represent that information, and we still represent that data today. But knowing where things come and go to is one good example of why we need these world models. And so you can think of how these world models are applied, and you can almost reduce it to the exchange of water and energy into value, right? Into money. And the way it's doing that is trying to understand what is going on in the world, computing it, and ultimately getting you to a goal. And so one of the things I kind of coined pretty early on is the concept of an agentic artifact. And it's kind of a misnomer because the word artifact means that it was man-made. But artificial intelligence also means that it was man-made intelligence. But so the purpose of a agentic artifact is that who here actually watched the YouTube video that was leaked from Google about the selfish ledger? All right, so nobody has. All right, so when YouTube was almost first started, one of the earliest videos that leaked, and YouTube was just getting its legs underneath itself as a search engine, was that they were developing a selfish ledger, meaning that they were planning to build a database on every person that would self-complete itself, and basically have an understanding or a digital twin of every person that through their searches. So not only would it know if you were like pregnant or not by your searches, but it would keep track of that. And people were just up in arms when we heard about privacy. But now today, we call that Facebook, and we willingly give that data. We call that TikTok, and we willingly give that data. So it's not so controversial today. But it kind of harped on the idea of back in the 80s, we had this concept of object-oriented coding, meaning you keep the data with the objects. So the prediction is that what if the media that we're responsible to create and the products that we're responsible to create were kind of object-oriented? What if you just gave them a goal and it would complete itself? The entire product lifecycle would be handled by artificial intelligence and agents self-completing a goal, right? So you can do your marketing with agents. You can do your manufacturing with agents. You can look into the entire so we learned that Gucci releases 65 products a day, right? Just to find out what is hot. Imagine the work that goes into designing, manufacturing, shipping, tracing, authenticating, putting it in stores, selling it, marketing it, all for every product. That is a lot of work. And so what if you could just say, hey, Gucci bag, make yourself prettier, make yourself more luxurious, make yourself more wanted. And you could do that for customer experience, you could do that for more sales, any goal. You could just give it to an object or an instance of an object and say fulfill it, right? If I wanted that plastic bottle to be recycled, I can give it an agent and say, hey, I want to recycle every bottled water that people see. And the person next to it, Mark, would get a notification on his phone and say, hey, like there's a piece of bottle there. You get like 0.0001 Bitcoin if you put that into the trash, right? So it's the idea that objects would fulfill their own goals. And so in order for this to happen, you have to have a nearly millimeter understanding of the world. And currently, the way we make information is flawed, right? Language has to be man-made. Games have to be man-made. A lot of images have to be man-made. And the problem with that is that it's going to be faulty, right? So for example, Amazon built hundreds of thousands of digital twins by hand. And then, when it came time to build Just Walk Out technology, they couldn't use it to track the elements within the store. And so 70% of the items that you would walk out with and all the transactions had to be hand curated. So they basically did, a version of like drone strike shopping, right? Where like a pilot at the other end who was supposed to be the cash register was checking on 70% of the transactions, right? So it's like a digital version of a register. And at the same time, right, the reason why the media for this, why VR and metaverse and a lot of these other ideas never took off, is because it limited us to the amount of time and money we were willing to spend on this data, right? So for the metaverse and video games to exist, they have to be bespoke, they have to be handmade. But everyone who here is wearing glasses, everyone who has eyes, like we exist in a fire hose of information, right? We don't have to create reality. We don't have to work to recreate all these things. It already exists. We just have to look at it. And so this has more content than a TV could ever give us, right? Oh, time. And so Google Maps is the closest thing that we have to this. You can almost think of it as a metaverse, like multiple businesses on the platform. So you can almost think of it as like the realization of what we wanted the metaverse to be in the first part. The problem with that is that all the way that we've constructed our information tends to lead to hallucination. It doesn't hold up in a court of law. But we are about to be outnumbered by the amount of sensors that are out there, right? There's roughly 10 sensors on your phone. There's 6 billion phones. So for every one person, there might be 10 sensors. That would potentially increase if you think about if sensors could be at the point in which insects and moles could exist, like it's 1,000,000:1 ratio. And so we're about to enter a time in which there'll be more sensor data than actual language, actual data that we can produce as humans. And so in the end, you can think of how all these fit together is that we'll use digital twins to help compose and capture the world through sensors. and that world models becomes basically our state, our memory, our ability to understand what is actually going on a very complex level. And we already have architectures today like Alpha Earth and Alpha Evolve that are deterministic models that will eventually end up replacing the language models that we have today. And that what we will use to pursue our goals, like to solve our problems, will be these agents, but they will no longer be limited to just digital data and what's on the internet. They will be able to work offline through the multitude of sensors, the multitude of robots, and the multitude of people that we have access to be able to influence. So yeah, so that's the conclusion, and this is my LinkedIn. If you want to talk more, feel free to scan. Resolving conflict?
Yeah.
On what is a world model?
Yeah, for these different, giving these different objects different goals.
Oh, in the not in the understanding, but in the goals.
Yeah.
I mean, it's whoever wants it more.
Okay.
So yeah, I feel that like there might be value or weight associated to these agents, and people who are willing to spend more will have to conduct themselves through their own network or other networks, or build their own network, and potentially that could help resolve it. But since we're not there yet, this is all sort of hypothetical.
So you said you guys are using these models yourself. Is there a problem that you can solve with the models that you're building?
Hallucination. So basically, a way to kind of reduce spatial problems is that who here today would use ChatGPT to give them turn-by-turn directions when their life is on the line? Nobody? All right, so we're not there yet. And the reason for that is ChatGPT wouldn't give us that information in real time. It doesn't have the understanding of this world. It would guess. I feel that even on a smaller level, since the web is mostly commerce, right? You still have ads to buy things, and you buy things, and people transact on those things. That it'll still be the business model that drives AI, right? For now, right? So most of commerce is about passing through supply chain, passing through stores, passing through. Like the most valuable thing in any room is products. There's 100,000 things in this room, and like most of these are products, right? And so we focused on digitizing the atomic because that was the thing that would be transacted. And there's a good behavior that we do today that equates to that, which is barcodes, right? We use barcodes or labels as a form of augmented reality through paper, and we use that information to attach whatever is in the box to a digital twin of information somewhere on the cloud. Face ID does the same thing, but doesn't require a barcode. And so the more accurate you can make the digital twin, like the one that's on your phone, the more accurate and the less you'd have to rely on barcodes to be able to transact information of traceability, of checkout, of visualization. So everything was sort of based on first principle, based on what we observe people to actually do. Does it make sense? Does that answer your question? Awesome. Any other questions? All right, well, thank you so much.